Here's an example of a application problem involving normal distribution. So let's solve part A. We have the average life of a brand of automobile tires is 27,000 miles. So when they refer to 27,000 miles as being the average, that is also the mean. The standard deviation is 2,500 miles. So let's find the probability that if a tire is selected and tested, it will last between 22,500 and 25,500 miles. So first we need to convert each of these to a z-score. So for 22,500 we have z equals that value, so you always start with the number you're converting, and subtract the mean from it. Divide that by the standard deviation. When you do your z calculations, always make sure that you round it to 2 decimal places because that's the way the table is set up. Also, when you evaluate this, make sure you hit equals before you divide by 2,500. This gives me z equals negative 1.8, so I'm going to make that negative 1.80. Okay, now if I look up z equals negative 1.80 in my table, we don't have any negatives, so we just look up the positive 1.80, and the area under the curve at that number is 0.464. Okay, so now let's convert the other value, which is 25,500. Okay, so z is equal to that value, 25,500, minus the mean, 27,000, divided by the standard deviation of 2,500. Okay, so press equals before you divide, and this gives me z equals negative 0.6, so I'm going to make that negative 0.60. Okay, so let's look up that value and get the area. So the area at 0.60 is equal to 0.226. Okay, so now that we have all of that information, we need to draw a picture. The picture is vital because it lets you know whether you're going to add or subtract these areas to find the value, the total probability. Okay, so in the picture, always put 0 in the middle. That's going to be where the mean is standardized. And I have z equals negative 1.80, so that would be on the negative side, negative 1.80. The other z I have is negative 0.60, so that's kind of to the left, halfway there, negative 0.60. So you plot your z's on the number line. Next you want to draw an arrow from 0 to the line. So from 0 to negative 1.80, the area is 0.464. So from 0 to negative 1.80, I have 0.464 area. The next one is from 0 to negative 0.60, and that area is 0.226 or 22.6%. Now I want to know the area between these, which is just this portion under the curve. So because my areas are overlapping and the arrows go the same way, I need to subtract when they go the same way to find the area between. Okay, so it's 46.4 all the way, 22.6 part of the way. So if I just want to know this piece, I want to find the difference. So 0.464 minus 0.226 will give you that region between those. Notice that when your z is negative, your areas are still positive. Area and percents will never be negative. So 23.8% of tires selected will last between 22,500 and 25,500 miles. Now part B is the same idea here. So you're just going between 24,000 and 29,000 miles. So again, same process. We're going to convert both of those. So let's go ahead and I'll just put the z's for each of those. So for the 24,000, I would do 24,000 minus 27,000 equals, and divide that by 2,500. This gives me z equals negative 1.20. Look up 1.20 in your table and you will find that the area is 0.385. Okay, so now for 29,000, 29,000 minus 27,000 equals, divided by 2,500 is negative 9.64. Check that again. Yeah, I thought that was too large. So that is going to be positive 0.8. So 0.80. So the area at positive 0.80 is 0.288. So once you have that information, let's draw the picture. Put 0 in the middle. Let's plot negative 1.20. So that's on the negative side, negative 1.20. And plot your area under the curve. So from 0 to that line is 0.385. Secondly, plot positive 0.80. That's to the right. So pay close attention to your signs. Negatives are on the left, positives are on the right of 0. And then I want to graph my area under the curve. And it always goes from 0 to your line. So from 0 to that line is 0.288. Again, I want to find area between these. So I want this total area under the curve between these lines. Well, notice that in this diagram, we have the arrows pointing in opposite directions. So I have 38.5% going this way, 28.8% going the other way. So the total is what I'm searching for here. I don't want to subtract these, I want to add these together. So when the arrows go opposite, you add, and when the arrows go the same way, you subtract. So 0.385 plus 0.288 gives me 0.673, or 67.3% probability.